If you come in, make sure your number is, if you come in, make sure your number is on, you have your number ready, and you have your number on your thing, and also you make sure you're on YouTube. If you come in, make sure that you're on YouTube. Write your number. You just write your number on YouTube. And make sure your number is on your thing. We're starting in 3 minutes. We have no time to waste. I'm not saying it twice. Is Alex here? If you come in, write your number on YouTube. As the class starts, I kick everyone that's not on. All right, let me see. 66, 43. Let me start from up. 17, 12, 21, 14, 07. Is Alex here? All right, 2 minutes and we start. If you come in, make sure you write your number. So is Alex here? Not yet. You guys are not wasting time again today. We're not wasting any time, not even 1 second. If you come in, let me repeat it again. Type your number on YouTube. If you come in, type your number on YouTube. Nabil, I don't see your number on YouTube. Salvador is not getting in. Once I give you co-host, Salvador is outside.
Uh,
Franklin.
Hold on a second.
It's Alex here.
Alex is not here yet.
Franklin, please, you help me with one thing. Hello, Franklin, please help me with one thing. Please just be checking for anyone that do not have their camera on. Please just boot them out without asking any question. And they won't be able to get in, no matter who person is. Help me with one.
Give tech, I have an issue with my camera. The drivers are not.
Please just put them out.
My camera is on, but it's not visible.
They won't be able.
Sir, can you see me on YouTube? Hello, sir. Can you please hear me?
I do not see Nabil.
I'm on YouTube right now. I'm on YouTube and Zoom. I don't know. Let me try to
Type your number, your 122, and I don't see 122.
hold
Colin,
on.
type your
Hold on.
number instead. All right, let's start. I don't have time to wait today. I
I'm
don't have
looking for
time
the
to wait.
place. I'm looking for the
Is
place. I
Alex
have
here?
to.
Thank you very much, Franklin. If you guys don't help me like this, these recalcitrant students will disturb someone to hold this class.
I can tap my number. Oh, shit.
And by the time I see you drop out of YouTube, different people are taking care of that. By the time you drop out of YouTube also, boom, you're gone. I don't have time to waste again. We are 3 minutes late.
Where can I tap my number?
Yesterday, the lesson I prepared, I could not teach because of all trying to like get things done. 1, 2, 3, 4, 5, 6. What am I looking for? I'm looking for mobile extent. Let me clear my screen. Can you guys see my screen?
Yes, sir.
Yes.
Oh,
Yes.
why is my speaker not connected?
What's
Oh.
this?
You guys hear me? Hello?
Yes.
Yes,
Yeah,
sir.
yes, sir.
I can hear you. Yes, sir.
Okay.
Yes, sir.
All right, I have 2 terminals here. Use this one for my notes. All right, can you guys see my screen?
Yeah, of course, sir.
Okay. All right, look at what's happening here. Some of you, you're used to this. You've seen this before. Okay, I want you to have this picture in your mind, okay? I'm gonna explain something with this picture that you're seeing right here. I'm gonna explain something and how it works. Hopefully, once I explain that, it will become a little bit clearer when I go to the system. You see, when you go to the store, what happens is, or when you go to a shop, what happens is there is someone, a cashier, that is always working, right? Now, these are items that this cashier is processing. He's processing these items, right? So now what happens when a process is not being, when an item is not being processed? It's waiting on the line, right? To be processed. This is how the CPU processes information that a computer gives it, right? So whenever there are more than 10,000 processes going on at the same time, and what happens is there are different stages of processes. Okay, good. Let me stop right here. You see, there are different stages of processes. Whenever the computer or your server is processing information or any executables that you've given, it keeps it. It gives it a process ID. It assigns it an ID. There is an ID tag on all these things. That's why it's scanning it right this, right? So when he knows that this is already scanned and done, he puts it somewhere. He delivers it and it's gone. Right. Now, the ones that are not being done also have process IDs, but their states are different. Oh, Alex is waiting. Uh, Alex, tutor Alex, good. Alex, please help us and get all those that are outside. Oh no, I admitted all of them. Yeah, those that are just getting in now. There is Coley, there's Nelly. No, not Coley. Coley wasn't there. Coley came in since. There's Nelly, there's Salvador.
Yeah,
Get
so.
Yes, there's Nelly, there's Salvador, and there was one or two other people.
Okay.
I'll check on the Zoom once I look at the meeting.
Okay.
Okay, and help me take the names of all those people.
Yeah.
Next class, they're not admitted.
I'm,
I don't even have to argue with any of them.
I'm really sorry about being late because of time of changing time. I didn't know
No,
that.
that's fine, Alex. That's fine, Alex. You are
Yeah.
working with me. All right. So let's continue. So these are different process states. We have different process states. Every process exists. There's something that we call a parent process. Every process stems from what? From the parent process. The parent process is always, that is, a process is a fork of another process. What do we mean by a process is a fork of another process? You are a fork of your parents, right? Am I right? You carry some part of your parents' DNA. Am I right? So you are a fork of
Yes.
your parents. To some degree, you're a fork of your parents. Now, when you're growing up, what happens is your parents, you have things that you're doing, right? When you free your room, at least you've become independent. Now your parents know that they've processed and finished. Now you can process someone else and you're done. I mean, just taking it like that. Now Why is it important to learn processes? Why is it important to learn processes? You should know that after learning processes, you should be able to get information about programs running on a system to determine what the status or the resource use and the ownership so you can control them. Why should you uh why should you determine ownership of a process? For example, if a process is supposed to use to run as, if a program is supposed to run as, let me say, um, it's supposed to run as John, then you check the system and it is user root that is running that process. There would be a problem. The application does not recognize user root or user daemon as the original user that has to run that application. But since it's happening like that, since it's user John that did the run, there will always be a problem. All right. So if I do a PS dash, let me just say PS AUX, I pipe it and I head -5. Now, you see, as we were explaining, this will bring me like processes, the first 5 processes. It will bring out the first 5 processes that were running at the time that I ran this command, right? And the 4th column will always have the process states. You can see I, you can see S, and more. So all processes are descendants of the first system process in Linux. What do I mean by this? Every process starts with systemd, which takes a process ID of 1 always. So I did head the first 5 processes in the system. You can see that the first 5 processes in the system all right, I think this is better. All right, you can see that the first 5 processes in the system, the first process that was ever created with process ID 1 is systemd right here. And it's at the sleeping state, right? The state it's sleeping, S, which means sleeping state. Now you can switch, you can see other processes that are running in the system. So another way to see these processes, if I do a PS3, and let me pipe and head it dash, let me just head it to -10. Okay, this is a process tree, -10, because if I do process tree only, it will bring out a tree. Ça va montrer la structure de tous les, bon, appelons ça procès, de tous les procès dans le système. If I click enter, you'll see it's so much that I can't even scroll. Well, it's not even that much, right? I can scroll. You see? So we see that when you run PS3, the first ever process that started was systemd. When systemd started, it started all these other processes. So these are child processes to what? The systemd service. These ones are child processes. Firewall-D, cron-D, all these other processes. It started these processes. Then it started SSD, right? Systemd. Also, it started a process that's called systemd, which also started other processes, which this one started another process right here. The SSH process started SSHD, started 10 SSHD, started these processes. So this is like a process tree. The genome, what makes you have like a GUI, right? A GUI interface. It was started by what? Systemd, which is a child process of systemd, systemd-sdpam, which is a child process of systemd. And that process in itself, genome, started another process, which was iBurst. You can see it right here. If you go down, you can see other processes, Vim tools, and other processes that were started. Okay, this is the life cycle of a process, right? This is a life cycle of a process. I hope you guys can see a little bit. This is a life cycle of a process. When we say fork, that means a new process, as we saw seeing it right here. Are you guys with me?
Yes, sir.
Are you guys with me?
Yes, sir.
Yes.
Please, next time when someone will give a reason why you did miss the class, you will not more be part of the class, please. Nelly, please take note. We can't keep on doing this every day. You see, just what you're writing now about your class is disturbing my class also. I'm trying to explain something for people to understand. All right, let's go. So with a fork, right? Systemd is the first process when the system boots up. The first process that creates a systemd. Now, new projects, new ones start forking out of what? They fork out of this process right here. That is this term. They come out of this process. And when they come out, it is scheduled, right? It is scheduled. When a process is first run, that process is scheduled. And when that process is scheduled, you see that the process is runnable. The system checks to make sure that that process is runnable. If the process is not runnable, it rejects the process. That process goes into like a stop state, right? T, into a stop state. It's not running. It's not doing anything. You see, that process isn't running. It's not doing anything, as I rightly explain here, right? As I rightly explain here, it's not running. Now, if it is runnable, then it resumes, right? And go to a running state, and it will start running. Once it starts running, once you see it running, it will be in a running state. Now, when it's in a running state, it will run. But when it's not running, it will wait. When it's finished, it will exit. Now, why will a process wait? Why will a process that you were running wait? It can be waiting for one thing. It can be waiting for another process to finish before it runs. Let's take an example. Clear my screen. Let's see. Now, if you're in the system right now, if you did log in through VPN, if not, I'll give you guys 1 minute to log in VPN, log into this server. 1 minute starts. Let's go. Use the Linux class VPN and log in. Use the Linux class VPN and log in and get into this server. The 1 minute is counting down. You would have already been there. Great. Thank God. You guys are in. The ones that are in are in. Okay. I'll give you a few commands. Really observe on your screen, on both screens. Let's observe and see what's happening, right? Now, let me do a yum install HTTPD. Okay, HTTPD. Now here, right here, I'll switch very fast. Right here, I can do PS AUX. I pipe it and I grep for yum. For now, see, there is no process. This is just the process that I started. Even a command that I launch is also a process, right? Now, I'll launch this very fast and come back here. You can write also this command to see what's happened. Once I launch this, you press enter. Once I launch this, you press enter. Oh, let me see. Yum install, yum update. Let me do a yum update so that it will take much time. It will take a longer time. Yum update to update the system. There might not be there might not be any update. Let me do a yum install AutoFS. If it's already installed, Nginx also. Let me install also what's not there that I can really install now. I can also install what will I install that will take time? I'm reading comments only on YouTube, please. Great. So let me just install these two things. Yum install AutoFS. Now we want to pipe and grade the yum process. Once I launch this, what will happen? From systemd module, it will create a fork, a new process, and that process will be assigned a process ID. It will schedule that process and see if it's runnable. It will run, right? If it's not runnable, it will stop and finish and tell you maybe this not found. It's done and gone. But if it's runnable, it will start running it. And at that point, when this screen is running things, like things are showing on my screen, if you do a ps-aux, you'll see that that process will be in a running state, right? That process will be in a running state. Let me just prepare it. The process will be on a running state. Then, if it goes through, then it will finish and exit. If it doesn't go through, something happens and signal that process to stop. That process will stop and wait for a signal to wake up. It will go to sleep mode and wait for for the signal to get up. For example, I've done a yum install AutoFS and Nginx. Once I launch it, it starts. I launch this. Now it could not go. Well, at this point, I see, okay, all right, look at what's happening right now. You see, the process is at a sleeping state. Sorry, this is the process, the yum process that I did run. It's telling me that your user root, let me see, let me go again. Okay, you see two things coming out. Let me clear my screen so you see it well. Remember, I said one will always be what you just ran. So this one is what I just ran right here. I just did this PS, this yum, but this is actually the process that is running. You see, you can see yum install AutoFS and Nginx. I can see it right here. So the process is installing yum, this and this. So what I ran was, it came here, it checked if the process was runnable. It said, yes, it's runnable. You can stop it. It's runnable. It says, okay, if this is runnable, bingo. I come here and it started running the process. Oh, something happened. It stopped. Why did it stop? It went down to a waiting state. Now it's waiting for a signal to go back to check if it's runnable. If that signal makes it runnable, the process will come back to the running state. When it finish running, it will exit. And once it exits, what will happen? It will signal, it sends a signal to the parent process, the PP the PPID, which is the parent process, to tell it that, hey, I have finished running. You can collect back all your resources that you gave me, right? Hey, I am staying at home, mom. Now I am going to college. Mommy, you can collect my room and give it to someone else. That's what the parent process does. The parent process allocates resources for the child process to run. Once the child process run and terminate, what does it do? It sends back a message to the parent process saying, you can recruit back your resources. I am done running. Then at some point, there's something called a zombie process. A zombie process is just a process that it has already sent out a message to the parent saying, parent process saying, I am done running. I am done scanning. Like we saw on the Walmart video here. What happened? He scanned this one and the person said, no, I don't want this one. And this one right here, what did he do? It's now aside. It's aside. Now this person is scanning and going. You see, he's scanning and going and allowing the other ones, right? You see, he allows the other ones. Some might be forgotten. You see, this one, the person rejected it. It's just standing there. The process ID will be there, but the resources have been freed because now there's nothing right here working. It has freed the resources. It's just hanging there till someone comes and pick it. Either you and I come and kill it. Say, oh no, this one is not needed. At this point right here, it is still standing right here. It's still standing right here. It's still right here, but on what? On the process table, but it doesn't have any use for what? The kernel to process it anymore. Are you guys understanding? Are you guys understanding? Okay. Yeah, I see positive. Let's continue. Okay. Coming back to what we did, remember what I said. A process might be interrupted for some reason. Salvador, you're not supposed to be in this class. Please, lock out.
Prof, I have a question.
Question.
Yeah, so it means when we run the command Control C, it's actually to stop one process, right?
Yes.
Okay.
Control C, you're killing a process. You say,
Okay.
this process, I'm stopping this process right now. You see, else the process will run completely. Now, this process right here is running. This process right here is running. If I do, it's at a wait state. When we say a process is waiting for something, it might not be this one. There are 10,000 processes that can be running at the same time. The input, it might be waiting for user input. It might be waiting for another application to run before it runs. Because the way the CPU works is the CPU might take one thing, the CPU takes one thing at a time, right? The CPU takes, let's say, takes one process and calculate it at a time. There might be so many things. You have been there. A cashier takes, if you guys are 5 of you or 20 of you on in a line in the store and you want your stuff to process, you stand on the line and you wait, right? Once the cashier processes one thing, it's done. But if there was only one item and one cashier, what happens? There is no wait state. Are you guys with me? There is no, it will take it and work it at and finish that process at the same time, unless that process needs something else. Now, if it needs something else, that process will go into a wait state to wait for that thing that it needs, to wait for that signal. Once that signal is given, what happens is that process will continue running. Now, if I do yes here, right? If I do yes here, this is a signal. This is an example of a process that needs a signal. What's the process ID? The process ID is what? 133 this. If I do top right here, you see, you see different processes. You can look for the process ID. You can also look for the process ID. Oh, let me see, PS-EF, pipe and grep for my process ID. What was my process ID again? This process ID. You see, I have my process here. When you do PSAUX, you see it better. Yeah, I can grab also for the process ID. It doesn't matter what you grab for. You see, the process is right there. Look at the state. The state is what? The state is what? Sleeping. So some of you will say, why is there a plus? Why is there an SS or S and another S? So processes in themselves also have sub processes, right? But we won't go into too much detail of all that. Now, let's say yes and press enter. It's going. I call it, right? See, you see the state is changing now. Do you see the state? The state did change to what? Running. You see? Now it's completed. It's gone. The process is finished. There's nothing, there's literally, that process is gone, right? Now I can't see that process no more. Yum. It's gone. Now, if I do a yum remove, the process comes back. You see, now the process is at the waiting state again. Do you want to remove? Yes, I want to remove. And you see, it's running. The process is running. Once my thing is completely removed, the process is finished and exit. So it went here, it ran and saw that it needed something. It went into a wait state, waited for that signal. When it got that signal, it finished, exit, told the parent process that I am done. The parent process took back the resources and it's waiting for another thing to want to use it. Is that a little bit clear? Question, Philly. Write your question. How do we identify a process? Let me ask you guys, how do you identify a process? Okay, great. Feli said, is this the reason why some computers are slow? That's good. You see, yes, that's the reason why some computers are slow, because some processes at some point might be waiting for other processes to play. Some of you here do play DV lottery and the like. They tell you don't play on the last day. Reason being that one. Maybe on the last day, what's happening is so many users want to play at the same time. That information needs to be processed. Now, the CPU can only process what? The CPU can only process a particular amount of information at a particular point in time that it's working. No matter how many things this guy can scan right here, if you put this whole store in front of him, he'll still be scanning one at a time, right? Now, what happens? The time allocated to finish each of this increases a lot. And that's when at times you see a browser, or you see when there's too much load, you see it doing this. Because whatever thing you submitted to be processed is standing on the line and waiting for its own time to be processed. right? It's waiting for its own time. Now, let me do something. Let me do something. Let me do something right here. I just want to show you this you guys this example. Let me see with root. I'll do it now. Uptime. Uptime. You can see the load average on the system is 0.03, 0. This. I will explain what the load average is and how it really works for you guys to understand. Okay, just look at the load average. You can take a picture of it, or you can, if you're logged into the system, you can also do the same things I'm doing. We are in the same system, right? You guys can be seeing the same things that I'm seeing right here. Do not run any command, please. I want to run a very dangerous command. And what will happen is if you run it also, you're going to blow the system. Please let me do the runs. Don't try it. Okay, so let me see. Let me see. Dd if let me see /dev /0 /dev /0 of let me see /dev /0 of equals to, let me send it to /dev /no /dev /no and run this. Great. Let me see, it works. All right, so this is like a very dangerous process. What this process will do is this process will consume all the memory in the system. I want to saturate the system with processes just to show you the reason why you study processes and all the like. Now, let me do this and do an and. See, that's the first process ID, second process ID, third, fourth, fifth, sixth, seven. What did I tell you yesterday? I told you that processes, when you use the top command to see the live processes in the system, the live processes in the system, the first top lines will always show you what processes are using the most CPU. If I do top right now, you see, it tells me that these processes right here, these are the first 5 processes, which are like DD. All these processes are using almost 28. One is using 29%. One is using 20 this percent of CPU time, of CPU load. This is using that. So the CPU is now suffering because the CPU is 100%. If you've used 28, 28, 28, 27, that means the server is getting slower. The time for it to process this one, it's getting slower. Everything is getting slower in the system. If I do uptime now, you see that the load average is dramatically increasing. Now, let me use this also to explain what a load average is. A load average is the load that is on the CPU, right? And how do we calculate that load? I'll just do this before I'll come back very small to tell you. See, we calculate that it shows the load on the CPU, the last 15 minutes. It's saying 15 minutes ago, you were at 0.57. 5 minutes ago, you were at 1.57. And 1 minute, you're like at 4.71, which you see, the more it's telling me now that my load is increasing. Look, you see, my load is increasing. It's now 590. How do I know this load is high? Because I need to check the number of CPUs that I have. If I do ls good, someone is saying that it slowed the server. You guys now are, if you're logged into this server right now, you understand that the server is now kind of, it's really, you understand that the server is not more working as it was working before, right? It's now slow. Now, since all this is running, this is the same server. Let me you see, look at how much time it's taking now to log in. You see how much time it took to log in? Now, let me exit and log in again. See, you see, because the wait state is increasing. Now what's happening? The server itself is facing an issue logging in. everything becomes slower. Imagine that there were applications running right now. What's happening? Everything is becoming slow. And now you start getting alerts, alarms that the server is slow. The server is slow. What's causing the server to slow? Well, I can do a top first to see. I look at the processes. You see, the more it's dividing this time because it says I can't kill myself. Look at the state of the processes. These ones are idle. Some of them are idle. Some of them are in sleeping state. But all these other processes are right here running. You see, it's at a running state. You can see all of them at a running state. And everything now that we're doing, it's becoming slower. And the load will keep on increasing. If I check the load again, see the load is now at 10.88. That's crazily high. Now, if I want to do a yum install AutoFS again, look at how much time it's taking this time around. See, look at what the system is doing. Did you see how much time it took just to start it? Because it's trying to say, the kernel is trying to like make space for other processes to run. Now, let's say if there was a user application, this was the Amazon website that people are buying stuffs online. What will happen? You click a web page to go buy something, it's doing this. When you say yes, see how slow it's going. Do you see? Before it was running so fast that you could see it. Now, at this time, you see how slow it's going. Are you guys understanding? I don't see your reactions. Now, yum remove this. Yum remove AutoFS. Yum remove AutoFS. We want to remove it before it was very difficult for us to see it because by the time we were going back, it was already done. But now you can even go back and see it. You see, even to type, everything becomes sudo-i. Everything becomes so slow. Look how much time it's taking just to get me in. Now, ps-aux, I pipe and I grep for yum. Okay, nothing is running. Now, if I launch this and I grep for yum again, you see it's at a running state. We were able to catch it at a running state. Before we were unable to even catch it at a running state. Now we caught it at a running state. We said when you see this color auto, that's what I did run. But this is the process. With the process I did this. We caught it at the running state. Now it's at a stop state right now. No, it's at a waiting state, waiting for a signal to go. I'm just using this one as an example. There are 1,000 different, it might be waiting for another application that it's not even me to give the input. It's that application to give the input. For example, if you query your identity on a web server, the web server is running HTTPD or Apache or Nginx. The web server needs to query what? The database before getting that info from the database, then supplying you that info. What will happen is that process will start, run, and maybe Nginx or Apache that you're using will say, oh, wait right here. This guy wants to contact the database. It will throw that process in a wait state. Then create a new process for the database, which will go to the database, fetch the information, give it. It will say, oh, I have the database. I have it now. Let me continue. It will signal the process. Behind the scene, you don't see it. Behind the scene, it signals it. It goes back to a running state. Boom. Gives you your answer. You're done. All right. So I want to remove this. Now, if we cut this thing at a running state, by the time we run our command, this is our process. We are interested in this. This one is just this process that we run, this one, but we are interested in this process. We cut this in a running state. Now we know, you and I know that this process is in a wait state. Now let's launch this. You see? Now the process that was in a running state is now in a sleep state. And if I say yes, as it's going, we call it again. You see, we catch it again in a running state. At this point, when we do uptime, it's so high. It's so high. How do I know this is high? What makes me know this is high? Well, how many cores do I have in my CPU? Remember, I've asked some of you to build CPUs with cores, right? If I do ls CPU, I pipe and I grep for CPU, okay? I can see that I have 2 cores on my CPU. I have 2 cores, right? I have 2 cores on my CPU right here. It's an Intel Xeon processor. So I have 2 cores, but the load average is 10 point something. How do I know this is high? If my CPU is 2, a load average of 1 will be 50% of my CPU being consumed. Are you guys with me? That will be 50% of my CPU that's being consumed. If the load is at, if I have 1 CPU, so now let me say this. If I have 1 CPU and the load is at 0.5, maybe 1, 2. In these 3 stages, this is the last 15 minutes, this is the last 5 minutes, this is 1 minute. This is the earliest. This is the most accurate one, right? This is the most accurate one that's happening to the system at that time. 5 minutes ago, it was this one. Then 15 minutes ago, it was this one. So can someone, yes, someone says I have different values in the same system. The thing is, it's a live thing, something that's live. There are millions of stuffs going up at the same time, going on at the same time. Even if I myself, if I take it again, uptime, and just take it again immediately after, do you see a difference? Because it's trying to free formation, it's asking the question. It's trying to free, it's trying to like heal itself, it's trying to like create workarounds, and solve the load issue on the server. Now, who can interpret us this load right here? The CPU is 1. We have this. So we'll say the CPU at this point was at 200%, right? It was at 200%. Here, it was at 100% utilization. Here, it's at 50% utilization. Okay, right now, in the system right now, we have 2 CPUs. And you can see on my screen that the last one was 5, 10, 12, as we're seeing. We have 2 CPUs. Can someone give us the percentages? I didn't do math in school. Can someone give us the percentages of this utilization? We have 2 CPUs. Let's just take 5, 10, and 12. We have 2 CPUs. 15 minutes ago, what was the load on the server? Can you guys write? Someone said 500%. Is that true? Komi, I didn't do math, but I don't know if that's correct. I think that's wrong. Komi, je te donne 500 de partager ça à 2 personnes. C'est combien? 250, hein? Right. Because if it was 1, if it was 1 right here, let's say it was 1 right here, or let's just say instead of the 2 CPUs that we had, it was 1 right here. This will be how many percent? This will be 500. It will be 1,000. It will be 1,200, right? 15 minutes ago, the server was loaded. It was at 250% higher. So it's the load average of the system is very high. At 250, it's double. The time that it was using to process a single thing is now like twice that time, more than twice that time. At 10 now, it's around 500%. That's 5 times more. If it was processing, if I did a Yum update, what was taking 1, it's taking like it's 500 times more time. This is around 600 times more. But if I had a load what will happen if I had 10 CPUs? Let me say, if I had 10 cores or 12 cores. If I had 12 cores in the system and you see this load of 12, or let me say 20 cores in the system, 20 cores CPU, and I have a load of 12, 10, 5. Will I say this server is healthy or not healthy? You guys should respond. Will I say the server is healthy or the server is not healthy? If I have 20 CPUs and I see this, great, great, you guys are understanding. Then the server is healthy. So to explain, the load average is always, how do you say it? The load average is always determined by the number of CPUs in the server. It's not because I see 10 here that I'll say, oh, the load average of the server is high. You go say that, someone will look at you as if you're crazy. Someone will say, but we have 64 CPUs in this system, and you're saying the load is high. How is it high? Are you guys understanding? Great. Thank you, Ashley. The CPU load depends on what? The number of CPUs in the system. If there is a single CPU or there are 2 CPUs, as we have right now, and the load is 12, what happens? The system becomes slow. The system dies down. You cannot do things easily again. Okay. Oh my God, I broke my tablet. Shit. All right. So right now we have a problem. What's our problem? Let me see. Everyone type. Everyone tell me what the problem is. Some people are just sleeping. Everyone type. What's the problem we have now in this system? What problem do we have now in the system? Type. I don't see. The system is slow. The system is slow. Right. Someone is saying the system is slow. I need to see everyone. If you're logged, if you're in here, no matter who you are, please type. Good. The system is slow. It is slow. Great. I see that, Francois. Great. Now the load average. Thank you. You're catching up, Francois. That's good. That's how I know you were lost, but you're catching up now. So Yasin said the system is slow. That's good. Very slow. Great. You as an engineer, you're working. The CPU is high. The load is high. How do I know the load is high? Well, I know the load is high because my interest is not too much on this one. My interest is on what is happening right now. This is what was happening since. What is happening right now is this one. I mean, 15 minutes ago, 5 minutes, it takes an average. It makes a sum and say, okay, 15 minutes ago, I was feeling a little bit like this. Now I am feeling a little bit like this. I'm feeling this. It always adjusts that. Now we're having a problem. You log into the system. You've received an email or an alert saying the CPU, the load on the system is high. The first thing you do is, if the load on the system is high, what will I do? Well, first, let me do uptime. I do uptime. I see, oh, 12, 14, 11, 81, 8. Huh. Okay. Well, I don't know if this tells me. This alone does not tell me if this system is having a high load or no. Right? I can have 100 CPUs. I don't know. This alone doesn't tell me anything. This just tells me that there's a number called 12, 14 days. I need something to compare this to now. I need something that I will compare these numbers to. If they ask price, if you are asking me something, it was $1. Then if you were asking $1 for something, I was giving you that $1. Now you're asking $12 for it, whereas I have $1. Something is happening. So I do LSCPU to check what I have as CPU first, right? LSCPU. Or another way for looking for CPU is you do a cat/proc/CPU info. I think it's CPU info. Yes, you pipe, let me pipe and grep for cores. Great, I have 2 CPU cores, 1 and 1. These are the 2 CPU cores that are in the system. I can see that there are 2 CPU cores, right? This is another way of, I see that there are 2 of them. There are 2 and the system is asking 12 CPUs. But the system is, the workload on the server is asking 12 CPUs to get that done very fast. But the system is offering only 2. So there is a problem, which takes us to the next lesson. How do I know the size of every core? Brian, this is the size of the core right here, 1. Each core is represented with a single value. That's why you see it in the proc info. It's separated. Brian, what do you mean by 1 gigabyte? What do you mean by 1 gigabyte? The
I
size
mean,
of the CPU
the
is
side
not
of each
measured.
one.
The size of the CPU is not measured by gigabytes. Okay. The size of the CPU, the size? No, CPUs have, let me say CPUs, you count the number, there are CPU counts. You count, like you can count the cores per CPU, right? You count the number of cores in the CPU. The speed of the CPU now, if I do LSCPU as I did here, you can see the
It's in
speed
in hertz and
in
frequency. Yes.
frequency. Yes,
Yes. Thank you.
how fast
Correct.
it
Mhm.
works, how fast that CPU can actually do something. It's 1, yes, but how fast can that one thing work? Okay. Is that
Mhm.
what you were trying to ask?
Yes. Yes. Thank
Okay.
you.
All right. So with this, we move to the next section of our lesson, right? Thank you, Become DevOps. Thank you. Yes, you guys should just be helping me like that. Anyone asks a question that needs help, please, you guys should just look and help. Okay, so the process state, as we said, is on the left-hand side. We go back to processes from what? Let's leave the load average and we go back to processes. PS AUX pipe and head -5. Give me the first 5 processes that started. And see process ID 1, process ID 2, process ID 3. Right here. Head -6. Okay. So you see the process and the process ID right there. And now, as we said, if I do what? A top right here, I'll get the processes that are consuming most memory and I'll see their state. I'll see if it's in the zombie state, wait state, running state, idle state, and all the like. This is the task report. The task report. This task is reporting as running. This task is reporting as idle. This task is reporting as what? Sleeping, right? Sleeping, as you saw up here, there are various stages of sleeping. We call them, there are various letters that are used to represent processes that are in a sleeping state. Okay, there's a K, there's D, there's S, and there's I, as you're seeing it right here. So whenever you install any application and that application is running, when you start that application, always, as a good practice, always do a PS AUX to see if that process is running. So you can see that all these processes right here, these ones are actually currently using CPU time. Any process that is currently using CPU time is in a running state. The process that is not using CPU time is not in a running state. There are 5 states of processes. There are 5 states. You will go look for those states and you will write notes on them, on the 5 states of processes. Now, killing processes. Great. Now, you have to send a signal to a process. Remember, when it was in a wait state, a signal was sent to that process and boom, it was done, right? A signal was sent. There are so many kinds of signals that can be sent to a process. There are so many kinds of signals. So signals report to an event. Signals report events to an executing. So it reports something. It sends something to a program that is already in execution. So it can send what? An explicit request. So what kind of signals? What are the events that can generate what? A signal. It can be user input, as you and I did here with yum install. And we saw that when we did a yum install, the signal, the event that generated that signal was to wait for what? An external event, which was you to type yes, right? Now, if I can do like yum install httpd, great. This generated what? A signal. And that signal caused the process to stop because this could not be processed, right? So either a signal is an external event or a signal is an error can cause a signal to the process. There can also be time, a time factor, which can cause a signal. Okay, we're just reading this stuff. Okay, so what did I say again? I said, okay, I was talking about time. I was saying that time also can be a factor for processes. There can be a timer on a process. A process can wait. At times, processes are being given like applications give timers to time out to things, not to bloat applications, because if multiple processes are being generated and they are not terminating and they are not actually being processed, what's happening is the application will crash at some point. So at times, on most programs, we give what a timeout. If this process has not been processed by this time, maybe in 30 seconds time, if this does not process, send a signal and kill this process. That's also one way that a process is being killed. Okay? You can use pkill to send a signal. You can use the command pkill to send a signal, right? You can send a signal by yourself by using pkill, okay? Which you can use it to kill one or more processes which match selection criteria, right? That means if I do pkill and I add something, for example, if I do a PSAUX here, sorry, do a yum install AutoFS. Oh, this is slow. I do a yum install NFS. Great. One thing that I forgot. When you launch two things, each thing you launch creates a process. Yum install NFS server. Each thing that you launch creates a new process, be it a new command, right? What? Let me see, yum install Nginx. Great. So now, if I've launched two instances of yum, if I do ps aux and I pipe and I grep for yum, do you see? I have two processes. One is install what? AutoFS. Install AutoFS, and the other one is installing what? Nginx. So every command that you run generates a different process. Look at how the process IDs are different. Do you see the process IDs? Very, very different. So I cannot just kill yum. NFS-utils, thank you. So I cannot just kill yum. I can kill this one and I can kill this one. On Red Hat 6789, they used to separate these NFS applications to 6 and 7, the first versions of 7. From 7.3.7.4, I think they started changing it and using NFS-utils and putting all the packages in NFS-utils. So let me see right here. Let me see right here. Okay, so we have two processes right here running. We have two processes right here, this process and this process. Now, you can do a pkill to kill all these processes, or what you can do also is you can kill just the process ID, right? I can just say kill all also to kill with yum. I can say kill all yum. it will look for, it will kill every process that has yum in it. Now, if you do kill-L, it will list you all the different signals. These are the different kill signals that you can use to terminate or terminate, and each of them have their usage. There is seek kill, and there is you might never use all of them, but the one you use mostly is this one and this one right here. Mostly you use these two. One terminates gracefully, one forcefully just terminates everything. So there's a create, secret. There are so many of them signals. When the server is deciding also on what to do on things, it uses these signals. It uses one of these signals to be able to act accordingly, depending on how the application was or how the system was configured to handle that particular problem. Now, if I do LL, I do W here, I see Linux class here. If I say kill, let me say, let me use a pgrep and see. Pgrep, let me use pgrep to grep -L -U. Let me see. Linux class. All right, I see every process that was started by Linux class, right? I see every process that was started by Linux class. Every process. Oh, I see everything. I can even see more details by seeing a W that is human readable, right? -U for user Linux class. You show me the screens, you show me how many instances of these users are logged in and all the like. You can kill all of them. If I kill all these processes, you guys will all, I think you guys should all be out. If I kill all Linux class, let me see. Oh, okay. No such process found. Yeah. Oh, these are your names, not processes. These are your names and not processes. Let me try it with a pkill and see pkill Linux class. Okay. It doesn't kill anyone. Let me just see. Let me see. Kill -9. Oh, kill -9. Let me get the process ID first before I can kill it. Okay. Who? Francois says kill -9 Linux class. Thank you. Kill -9. Kill -U. Kill all -U Linux class. Kill all -U Linux class. Okay, cannot get the UID from process status. Okay, great, that's fine. That's fine. I don't have time to kill it single-handedly. So the command sends a signal to, when you use the kill command, it sends the signal to a process by using the PID of that process. When you use a kill, it sends a signal to a process by PID number despite its name. Okay. So the kill command right here, it does not mean it only kills. It's used to send several signals, as I told you. Now PSAUX pipe and head -1 and let me see, PSAUX pipe begin and head. This will not work. And head PSAUX pipe and sort dash NR for then pipe it again. Nah, you can pipe and pipe. This won't work. Yeah, I wanted to pipe a lot of processes, but pipe and sort at the same time. Oh, let me see, NR4. No, it won't pipe. It won't do that. So let me just do a top right here. And we have a few processes here. Can you guys kill these processes for us, please? Use a kill -9. Okay, I can still see the processes. Great, I can see that it's reducing. Thank you. The more it reduces, the more everything becomes faster. Great. Great, search for their process IDs and kill them. You see, the more you're killing it, the more you can see that CPU is increasing. Each one is seizing the CPU by itself. Don't kill all. Parfait, don't kill all at the same time. You guys should kill by PID. Great. You see that when it becomes a single one, it's using total mem. And now there's still one remaining. Create your own processes. Don't create no DD. You guys should create processes. Let me see. Create your own processes. 5 minutes of exercise. Create your own processes. Mm. Jesus Christ. What happened? Hmm. I don't see Linux class again. What happened? Oh, so you were not using your user. Yesterday we said everyone create your user and work with your user. So why were you using your Linux class? Who kicked everyone out? Who kicked everyone? That's good. I like that. Who kicked everyone out? Everyone that was using Linux class. Someone just kicked all of them out.
I think we deleted their process. I
Who
don't.
did that?
I think I deleted one of their process ID. I don't know.
You're being a bad one, huh? Okay, that's good.
I'm not sure.
That's
I
good.
was just reading the ID and deleting, so I'm not sure if I'm the one who deleted it or not. Mm.
Mm. You needed to create your own IDs. You were asked to create your own IDs, right? If you guys see anybody in with Linux class, please delete that process ID. Be very, very ferocious with that. Any process that starts with the process ID that has Linux class, you guys should take it out. If someone logs in, that person should change fast, switch fast, and go create your user. Else, you'll be kicked out by your own friends because you don't follow rules. You want to do what you feel is good for you. Is the lesson understood?
Yes.
Questions? Please, guys, respond online, please. Questions? So we've done processes and we've done what? Load average, right? Have we done load average or you guys want us to do it again? No, load average, that was really well explained. You can just go read on it and make your notes. Are we good with load average? Hmm?
Prof, we can't hear you. Don't know if you're speaking.
Ashley, everyone in class, guys, wait for me in like 2 minutes. I'll be back in like 2 to 3 minutes, okay? Hello, who on YouTube is DevOps, the DevOps guy on YouTube? Franklin, is that you? Hello? Hello? Am I muted?
We are hearing you.
No, also you hear you.
On YouTube, who is DevOps? Who is the DevOps guy?
It's Franklin.
Oh, Franklin.
Yeah.
Hello?
Yeah.
Are you here, Franklin?
Mute.
Oh, Tutor Franklin, please, can you explain a little bit in French for the people that are French speaking, so that they just like have a general knowledge of what we did today, because some will not even like know what we were doing. Please. Should I? Hello?
On ne t'entend pas, Franklin.
On n'entend pas.
Phoenix, please help us. Phoenix, please help.
But I need to explain what the process is. Or what?
He said someone can explain what we just went through in French so that the French people can understand what we are talking about, because the language might be a problem for them to really get what the prof explained.
Ouais, vous voulez te me tuer. Ah. Comment tu veux m'expliquer maintenant ça?
François wants to try.
Ça peut aller. En fait, je peux expliquer, mais pas aussi à profondeur que Yves Tekin.
C'est déjà un début, patron.
And let me see. Antaji que vecino. Alex.
Tu m'as appelé Phoenix.
C'est toi l'administrateur.
Tu veux que je te...
Il
tu
faut
veux que...
expliquer, il faut expliquer en français pour pour les autres.
Euh, c'est ce que j'ai compris. Hum, le professeur a parlé de processus, en fait. Il y a différents statuts de processus. Il peut être en running, en sleeping. Et, si je comprends, si j'ai bien compris, il y a aussi le statut WIT qui comprend différents statuts qui vont du K, D, S, I, en fait. Euh, on peut tuer des processus avec la commande kill-9 et le PID du processus, en fait. Donc, le PID, voilà, c'est le numéro là qui s'affiche, je crois que c'est la deuxième colonne, non, la troisième là, attendez, la deuxième colonne. Bref, c'est la colonne qui est écrit
Deuxième
PID.
colonne.
Ouais, deuxième colonne, on va dire. Et le professeur a fait allusion au load average, en fait. Load average, si j'ai bien compris, j'étais un peu distrait, mais bon, je peux expliquer. Il y a trois chiffres. Si on va de la droite vers la gauche, je crois, c'est 15 minutes, 5 minutes et 1 minute. Et ce qui nous intéresse le plus, c'est la première, parce que c'est la plus récente en fait, qui fait allusion à la consommation du processeur. Et ce nombre est régi par le nombre de cœurs du processeur qu'on a sur notre machine. Voilà. D'où la commande LS CPU, il agrèpe CPU, ou bien il a fait la commande, si je ne me trompe pas, 4/pros je crois, il est arrivé jusqu'à CPU info, un truc comme ça. Donc, c'est vraiment régi. Et il a fait des calculs, bon, il a fait des calculs. Il a dit que le premier chiffre qui est sur la gauche, si je me trompe pas, par exemple, si on a un cœur et que le chiffre est déjà à plus de 1 ou 2, ça veut dire qu'on est déjà en train de surconsommer le processeur, en fait. Donc, le processeur tourne beaucoup trop. Voilà, donc c'est le petit calcul qu'il a fait. Il a pris un exemple avec un processeur qui a 20 cœurs et le numéro était à 20, le premier numéro était à 20, donc du coup, il a demandé si bon, c'est quoi l'état de consommation bon, du, du processeur. Plus le processeur est overload, plus la machine est lente en fait, le système est lent. Il a utilisé quelques commandes que je n'étais pas très concentré. Mais bon, je pense que c'est un peu en gros le cœur de ce qu'il voulait qu'on comprenne, c'était le load average, parce que c'est très important pour nous en tant qu'administratif ou bien ingénieur de vraiment regarder. Et c'était la commande Uptime qui permettait d'afficher, entre autres, cette information. Et la commande Uptime, il y a beaucoup de paramètres qu'on devrait prendre en compte, entre autres le nombre d'utilisateurs qui est connecté, depuis combien de temps notre système tourne et depuis combien de temps le système est allumé. Voilà, c'est un peu quelques informations que je pourrais apporter. J'étais un peu distrait, voilà, puisque je suis arrivé en retard, j'étais un peu paniqué parce que voilà, il m'a donné une tâche que j'ai pas pu, parce qu'il a le de temps un peu. Donc je suis désolé si je peux pas expliquer plus, mais bon, j'espère pouvoir déjà revoir la vidéo et pouvoir expliquer un peu plus à, à ceux qui voudront bien, quoi.
On appelle le processus comment en français?
On appelle ça, je crois que c'est les daemons. Moi, je pense qu'on appelle ça les daemons, en fait. Le processus, on appelle ça les démons.
Non,
Voilà.
oui, il y a les démons. Il y a les démons. Bon,
Mais en
disons
français, on dit
que
aussi processus, non? Je vois
processus.
processus aussi.
OK. Donc, ce qu'on disait, c'est que les processus, le français, s'il va être,
Oui.
ça peut assassiner quelqu'un. Mais bon,
Il faut essayer,
on va
là.
essayer. Bon, ce qu'on a dit, c'est que dans le système Linux où dans les ordinateurs. Les ordinateurs travaillent avec le CPU ou CPU, c'est encore quoi là? Encore
Le processeur, le processeur.
le processeur. C'est le processeur qui fait tous les calculs. On a déjà dit ça ici. Bon, ce qui se passe dans la machine, c'est que le processeur calcule, disons que le processeur calcule une seule chose à la fois. Comme on a utilisé la vidéo ici pour démonter, n'est-ce pas? Que, disons que ça, c'est le processeur qui est en train de, ça, c'est le process qui passe et le processeur calcule. Donc, ça fait ce que ça devait faire. Maintenant, tu vois ce qui s'est passé ici, là, hein? Il a scanné l'autre ici, là. Regarde, il a scanné l'autre ici. L'autre, dès que ça finit, ça termine, ça finit, ça termine. Mais il a scanné l'autre ici et mettre à côté, tu vois, et oublier l'autre ici. Ça veut dire quoi? On appelle ça un peu, bon, appelons ça un peu les processus zombies, que le procès est fini, le procédure est fini, mais l'identité, c'est toujours là. C'est toujours là dans nos process, mais bon, ça n'utilise plus rien, mais c'est seulement là pour prendre la place et tout ça. Et on a dit que le premier processus qui est créé lorsque tu démarres le système, c'est le processus système D. Et le système D, c'est le premier processus et ça, le processus identification de 1, avec le processus ID 1. Et le start de processus, c'est toujours au quatrième, euh, vers le quatrième truc, c'est ici là. Là où tu peux voir les différents stages de tous les processus. Soit un processus est en attente et en utilisation, ou on appelle running quoi, est en train d'être process, est en train de
En exécution, je crois.
en exécution, voilà, merci beaucoup, est en exécution ou c'est en état d'arrêt. Et lorsque c'est en état d'arrêt, il y a des fois, c'est difficile de voir un processus qui est en état d'arrêt. Parce que lorsque c'est en état d'arrêt, des fois, tu vas voir T. C'est difficile aussi de voir les processus en état d'arrêt. C'est pour ça que tu ne vas pas trop le voir. Tu vas voir, suivant, tu vas voir running et tout ça. Et sleeping, ça ne veut pas dire que le processus a un problème. Que tu as vu ici, il y a sleeping. Il y a au moins trois différentes lettres d'alphabet qu'on prend pour représenter le processus en sleeping mode. OK? Il y a K, il y a D, il y a S, il y a I. Il y a I aussi. Là, on est en train de voir le, le I. How do we call report in French? Le rapport. Ça, c'est le rapport. Donc, là, on peut lire ça en disant que le rapport de ce processus, c'est en mode dormi ou ça attend quelque chose. Peut-être ça attend que toi, ça attend un input, le input et output. Ça attend un input ou un output de externe. Si c'est interne, il y a les applications qui attendent d'autres applications. Par exemple, si tu es en train de, lorsque tu fais ton WhatsApp, tu veux login sur ton WhatsApp, il y a l'application WhatsApp et il y a ce qu'on appelle la base de données. C'est database, base de données, right? Lorsque tu envoies le process, c'est pour quoi? C'est pour WhatsApp. Mais lorsque WhatsApp vient là, pap, 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 ça court, ça dit que est-ce que ça peut exécuter ça? Ça dit oui. WhatsApp vient ici là, ça dit oups, je vais partir à base de données. À l'instant donc que ça part aux bases de données, le processeur ne fait plus rien avec ce process-là. Ce qui se passe, que ce process-là part en mode d'attente pour attendre le signal pour recommencer à être euh, exécuté. Lorsque ça attend le processus, ça attend ce signal, il y a un nouveau process qui est créé par la base de données pour faire les transactions de base de données. Lorsque ça finit, ça donne ça à l'autre. Oui, maintenant, WhatsApp a ce que lui il voulait. Il envoie un signal. Et on prend quoi pour envoyer ce signal-ci? Il y a les kills. Quand tu fais le kill-L, tu vas voir tous les signaux dans les systèmes, dans le système. Il y a le 6 alarm. Tu vois, prends ça pour envoyer les alarmes, tout ça, secret, wait. Il y a beaucoup de bon, disons wait, pour que ça met en attente, ça part en sleeping mode. C'est même pas toi qui mets ça. Le système prend l'un des là, un des là, pour exécuter ce que ça veut partir. Tu vois, il y a même 6 CPU ici là. Il y a 6 CPU ici là. Il y a 6 minimum time, 6 maximum time. Il y a tout ça, time, 6 time minimum, 6 time maximum. Donc, ça utilise toutes les signaux ici là pour faire pour réaliser, pour faire le système pour que ça fonctionne bien. Et on a aussi parlé de load average, comme on a parlé là, que le load average, c'est quoi? C'est je ne veux pas dire le poids, je peux dire quoi?
La charge, la
La
charge,
charge. OK, merci. Le français de la bourse, là,
la
un peu
charge
mauvais.
moyenne
Oui. La charge moyenne
du
du
processeur.
système, du processeur. Là, comment il va savoir que le processeur est en train de peser? Maintenant, le processeur ne pèse pas. Pourquoi? Parce que si tu as une force de 2 et tu es donné, et on te donne seulement 0,10% de charge apportée, ça veut dire que tu n'as pas de poids lourd, n'est-ce pas? If I do LS CPU pipe and grab for 1, 2, 3 CPUs. CPU. Ok, tu vois, là, on a deux corps de processeur ici, là. Et tu vois que le uptime, vous voyez que le uptime, c'est c'est à 0,5. C'est à 0,5. Ça veut dire que la charge n'est même pas égalité à 2. Si c'était à 2, bon, on disait que c'est 100%. 100%. Même à 100%, ça veut dire que ça utilise max 100% de sa force. Maintenant, ça utilise 0,5. On va dire que le système est vraiment, vraiment bien. Et la charge est mesurée en 15 minutes, 5 minutes et 1 minute. Il y a de cela 15 minutes, le système était un peu plus chargé. Il y a de cela 5 minutes, le système était aussi un peu chargé. Maintenant, le système est vraiment moins chargé, comme tu es en train de voir là. Donc, c'est ce qu'on a fait pour ajouter. Next topic. OK, next topic, c'est sur vos serveurs. Euh, tu vas partir sur ton serveur. Tout le monde va partir sur son serveur. Il y a les gens qui n'ont pas de serveur. Mais bon, OK, let's see. Tu pars sur ton serveur. Lorsque tu pars sur ton serveur, vous êtes en train d'utiliser, tout le monde utilise le truc. Attends, il faut
Ce,
voir.
ce qu'on a créé hier là, avec Linux
Oui,
Class, je veux
oui,
dire, chaque user,
pourquoi je n'arrive pas à entrer? Timeout. Attends, il peut y voir. Pourquoi je envoie le timeout? Why am I getting a timeout? Oh, okay. All right. All right. Vous voyez là, ici là, il y a les gens qui ont les serveurs ici là. Hier, on a vu les deux choses ici. Ça, c'est quoi? Ça, c'est les hosts, ce qu'on appelle les ESXi serveurs. Ça, c'est nos VM qu'on a ici là. Et vous avez les VM ici là. Il y a les gens ici qui ont leur VM, Groupcard, il y a Wilfried, il y a Arnold, ils ont les trucs, les VM ici. Il y a Alain, il y a Vanessa, tout ça. Ils ont tous leur VM. Ce que tu vas faire, c'est que, aujourd'hui, ce que tu vas faire, c'est que tu vas échanger l'adresse IP de ta machine. Tu mets ton numéro. Donc, le dernier bit ici, ça sera ton numéro. Mais si tu es le numéro 1, ne mets pas 1, s'il te plaît. Si tu es le numéro 1, tu mets 200. Parce que 1 est déjà pris. Tu edit your machine. Tu crées une nouvelle connexion. You delete this connection. Tu crées une nouvelle connexion. The connection should have the name. The connection name should be actually, for example, je vois que les gens n'ont même pas le user dans leur machine. All right, let me see. So next week we will start system D. Next
Question.
week, question.
Yeah, can we just drop the connection or we should delete it?
What connection?
I mean the one on my, because now I'm logged in and I can see that ENS 192 is up.
It's up.
Mm-hmm.
Okay, let's see. Let me do I don't know the command. You guys should give me the command. How do you see
NMCLI connection show.
LSCLI
NM.
connection?
NMCLI.
MNCLI
manager.
connection what?
Show.
Connection show.
Typo.
NM, not
The word
MN.
MN.
Thank you.
NMCLI connection
Thank
show.
you. NMCLI connection
Show.
show. I have a problem with this command. I don't expect anyone in this class to be telling me this right now, that is the first thing I should do. No, that is not the first thing I should do.
Device NMCLI.
The first thing is to check, tu dois chercher d'abord le device.
Okay.
First of all, start with the device. What if there's no connection? NFCLI device. Tu vois d'abord, s'il y a un device, oui, il y a le device. Et le device a une connexion sur ça. Now I can do NMCLI connection show. Okay, I know there is a device, and that's the connection name right there. ENS192 this. I want you also to name the same. I know I told you you can name it the way you want it, but I want you now to name it like ENS192, just to match it. Let's just match it so that will be easy for us to know, right? So that will be easier for us to know that, well, the device ENS192 has connection ENS192, not like connection actually has device ENS192. Let's just, I mean, it's easier for us to have it this way, right? Ashley,
It doesn't answer my question because I was like, because
what is your
I think
question?
initially you said we deleted to create a connection with our name. But now if everybody creates like a connection, we are going to have like 30 plus connections on the server.
Each person has, no. Each
Oh
person
yeah,
has
each
a
person
server.
has this, yeah.
You
So
have your
then,
server.
So then my
Nobody
question
can log
is,
into yours.
will I just drop that one and
Yes.
create mine, or I should delete it?
It's your choice.
Okay.
It's your choice, but at least at times I prefer you delete it. At times I prefer you delete it because now you can have 2 or 3 and one is primary and you don't even know, and you bring down the connection and you shut down your server and go. When you bring it up, comes up with a different IP. So if anything is not needed in the system, then don't put it in the system. Okay? S'il y a anything, le overhead, on appelle le overhead comment en français? Le switchage.
La surcharge.
Là où c'est la switchage. La switchage, il faut fuir la switchage avec tout le truc. Si quelque chose n'est pas nécessaire, don't do it. Don't keep it in. Pourquoi tu vas avoir 2 connexions alors que ce n'est pas nécessaire?
Div-Tech,
Question.
Yeah, Phoenix.
I have a question. So we can just modify that one, right?
Yeah, you can modify this one.
Okay.
Yeah. If I was you, even I'll just do NMTUI at times, but I don't want to teach you laziness. NMTUI, edit the connection, edit to oh, it's even automatic. You put it manual. Whose server is this? Let me get out of here first. Escape. This is someone's server, Rodrigue. Question.
Oui, j'ai une question.
Question.
Concernant mon serveur, je n'ai pas mon nom là-bas, c'est moi qui devais créer.
Moi?
Justement, en fait, je demande si c'est moi-même qui devais créer.
Oui, c'est toi-même qui va créer. You guys
Dans
compare.
les différents groupes.
J'ai créé. Là, tu peux voir que tout ça est déjà pris. Tout ça est déjà pris. This one, everything is. Qui a écrit ici groupe 2? Jesus Christ. Tu vois, il y a un ici qui est libre. Il y a l'autre
Donc,
ici.
en fait
Not in use.
hier soir, vous avez créé ça.
Si, put your name and your number. Put your name and your number. Pour que les gens connaissent que you have your server. Log in, put your name. You see, these are other servers. Hey, Wilfred has already taken 85. Great. There is still one server here free. On group 4, here free. There's this one also that is still free. In here, I can see.
I don't know. Je ne sais pas comment accéder. I don't know how to access.
You don't know how to access?
On this page.
Who is that?
And create mine, Brian.
Who?
Brian.
Brian. When you finish.
Je n'étais pas là hier soir. J'ai quitté hier soir un peu plus tôt.
Okay.
Je crois que j'avais fait ça hier soir.
Please, when you finish your. When you finish setting your network, please just type down on YouTube.
Okay.
You can meet your group members and ask them how it's done. They will tell you. And also, the VPN access, the Linux class that you're using, I'm sure by Tuesday or Wednesday, you will not be able to use it again. You have to use the other VPN when I fix the bug that's disturbing it. I think there's an issue with it, and I'll fix it. When I fix it, if you don't have your name in my list, you don't have access to the system. Easy as that. If your name is on my list, you have access to the system easily. This is already what I am telling you guys. What I'm showing you guys now is I've started preparing you guys for the first section of the exam, because the exam has 2 sections. This is a question in the exam. Let me just bring a question up in the exam and show you guys the first question in the exam, in the real exams that you take, what it looks like. See, they'll tell you to configure network, assign host name and IP address for this, as per the following. And they'll give you the host name and they'll give you the IP address, the net mask, the gateway. For example, if I give you this is my own example. Let me say this is my own sample example right here. All right. See my own sample example. Okay, configure network, assign host name and IP addresses for node1.example.com as per the following details. Host name, this. IP address, this. Net mask, this. Gateway, this. Name server, this. This is an easy thing. This is the first thing that you always see on all your exams. It will always, you have to configure network, IP address, host name, gateway, net mask, name server is DNS. The name server is DNS. Why will you not be able to do this? But if you write this, it will not work. So I told you, use the configurations that you already have on the server. You know what the net mask is. You know what the gateway for that server is. You've been setting network. Now, you see, now you're in a different environment. How do you look for the gateway? Already you're in the server and there's network in that server. How do you look for the gateway? Can someone tell me? What's the gateway? Ashley, what is the gateway of that network?
I'm still trying to figure out.
No, how can you be trying to figure out when you are SSH into it? You cannot SSH to a server that you don't know the gateway. You know the IP.
10.12.20.2.
Holy.
Oh, I'm trying to.
Holy.
Yes, Paul.
What is the gateway of your servers? You guys have your servers. You can tell me what the
24.
gateway. What? The gateway is what? 20 what?
You can't see.
This is the IP.
172.
Yes.
That's 16.12 and the
Dot.
one
Dot what?
the 159.
The 189.
Mine is not showing
Dot
an
one.
IP.
Ashley, yours is not showing an IP.
Yeah.
What is you're on Alpha Network VLAN? You're on Alpha VLAN. Everyone else is on Alpha VLAN. You're on Alpha VLAN. Ashley, yours is not showing an IP. Launch web console. Let me see what you're doing, Ashley. All right, type your commands. Let me see, Ashley. Okay,
I actually went to look for my IP, so that's why I kept...
Ashley, I'm seeing your screen. Let me see what you're doing. Type.
I was looking for the IP and then...
Where? On the line where you were looking for the IP. Let me see. On the line.
No, I wanted to put the IP.
Where?
IP for and then put it and then the gateway.
Okay. Well, what you did was you deleted the old connection without getting the... I can see up. Go up. I can see up. Let me do it for you. I can see here, Ashley.
Yes.
It's highlighted on your side also, right?
Yes.
Okay. I can see here that there was a connection in the server. You just entered and deleted that connection without having the information to configure the new one. So that's a little bit of a problem. Always make sure you have the information for a new thing before you're doing a
Yes.
change. Okay.
Okay.
So if the IP, I think, sorry, I'll have to wipe your thing back. The IP, it's 172 dot what 16.12, right?
Yeah.
Dot one. That's the gateway. The subnet mask
That's
is
okay.
the subnet mask is 255.255.255.0. I think so. That's all you need, right? You have your IP
I can't
already.
see the IP.
How can you be asking me the IP again?
Okay, no, sorry, it's fine.
Ashley,
No, I'm sorry. I understand now. I thought it would show up there, so I'll look for it.
no, you have the IP already with you. The IP will be what we explained last time is
12 dot
this
my
is the
number
network bit. Yes,
17.
right. This is the network bit
Yeah,
that you see right here. So you also have the same network bit, and what will
yeah.
be different
Then my
is
17 there. Yeah.
it's your server. What makes your server unique on the network?
Okay. Yeah. Thank you.
I've not heard Amina's voice today.
Hello, Prof.
Atu. I've not heard Atu today. Daryl. I didn't see Daryl today. Is Daryl here? No single thing from you today. That's not good. I know Jocelyn was represented very, very well. Nelly did one. Nelly was also represented very well. Faye is always there. Yes. Ashley, good. I didn't hear from Coley today. Coley, I didn't see any text from you. Let me check. I'm checking right now and see all those who. Let me copy a list of all those who participated in the class from YouTube. Let me see. Let me take snips.
So I have a question.
Question.
So assuming that I delete the device to enter a new connection, will I still have access to the server while working?
You have access to the console.
Okay.
You have access to the console. That's why this is the console. This is like your virtual box, right? This is
All
the
right.
console. So you can delete. It's only 40 sessions that you will not have anything.
Okay, sir. Thank you.
Sir, can I please take us back a bit?
Deleting my stuff again.
Yes. Who's taking us back?
Yeah, because yesterday I was able to connect, but today I'm kind of a bit confused.
Who?
I just want is Muma.
Yesterday you were able to connect. Today you're confused.
Yes, with the VMware, how do the credential we have to use to sign in?
My brother, that's not my responsibility. You guys, it needs to be your responsibility. I told you guys. You see, every day I should come and read. Why didn't you just take something, a piece of paper, and write down? You guys need to be
I heard that
doing
a
your
lot of
stuff.
things I just like got
Yes.
mixed up.
Next time, at least you write it again better. Imagine that there are 50 people trying to ask me the same thing. Is it serious, guys?
Ashley, why are you using your name? Teacher said to use the same name that you delete. ENS
I said use the
192.
device name. Yes, use also the device name just to match things. Hey, who is doing if name Ashley? My Jesus Christ. Ashley, there's no way you can run away from sharing your screen. Change the connection name also to ENS 192. This is where I'll see all your blunders. All of you. Let me go check on another person. Gaitan. Let me see what Gaitan is doing. Nothing. Vanessa. Okay. Vanessa is doing nothing. Rodrigue. Rodrigue is in Okay. Pascal Car. Okay, Pascal. See you already creating your stuff. That's good. Pascal, the other Pascal. Nothing. Not even logging. Alone.
So I have an issue with my VPN.
What happened with your VPN? If one person's VPN is working, everyone's VPN should be working.
It disconnect me all the time.
Disconnects you all the time. Yeah, I realized that Wilfred was having another issue also. Wilfred was having another issue too, which I realized. That's why I said the Linux class that you're using, you might not use the Linux class that you're using. You might not use it again because that VPN server has some legacy stuffs and some networks do kick it out because of that. But I had to meet today. You see, people try things and call me. I met today with like 2 or 3 people on this very Zoom class to fix their stuffs. Wilfred, did I help you today in fixing your VPN? I gave you a new VPN profile, right?
Yes, sir.
And you're using the new VPN, the Bernard VPN, right?
Exactly.
Yes, but when you use the other one, what happens?
My computer runs down.
Right. Guys, concentrate. Your server is your property. Very soon you'll start offloading logs. Very soon you have to connect your server with Active Directory in such a way that all other users in the system can access your server. You give them permissions. You manage them. All your friends in class, you manage them in your server. You give them access to specific files and directories and everything. You install applications. You give them the right to create their own containers. They might create containers in your server, then connect it with theirs and all the like. At the end of the class, you should be able to do all that. Coli, I didn't even see a single text from you today.
Est-ce qu'on peut avoir d'autres serveurs parce que nous autres n'avons pas? C'est
Qui
possible.
n'a pas?
Merci.
Il y a les serveurs ici, là.
Tout,
J'ai
tout
vu.
tout est occupé.
Non, groupe 2 n'est pas équipé. Ça, not in use, n'est pas équipé. Il y a 2 ici, là, qui ne sont pas équipés. Ici, là, il y a un. Ça fait 3 ici. Il y a 3 déjà ici. Tu vois 4 différents serveurs. Ici, il y a controller qui n'est pas occupé. Il y a 4 ou 5 qui n'est pas occupé. Je vais créer des autres groupes que personne n'entre ici, là. Ici, là, dedans, c'est quelqu'un d'autre qui est en train de travailler aussi maintenant. Et il est en train
No,
de faire son
Prophet, I
alphabet.
was typing on YouTube. Oh.
No, Koli, I didn't see you.
Yeah, I'm
Mimi too was lost today. No, I didn't see Mimi. Did I? No. Damata did not
my
type.
screen
No,
is locked. It's
Mimi was
locked up.
typing. So
Yeah,
how
I
can
did
I
type.
help? How can
Um,
I help you with your screen being locked? You guys will kill me someday.
yeah, I think you came to my section and I think,
Who is that?
it's 59 Felix.
How did I lock your screen?
Yeah, so that you came to my screen and after that.
I think that when you enter the screen of
Hello, Leon.
someone else,
Hello?
it is
Hey guys, hold on, class, please. Hey Leon, how are you doing? I'm doing good. You were supposed to be in class today. You're too slow in texting. That's what I don't really. You're too slow in texting. This thing goes fast, man. It really goes fast. guys that are doing the Ansible exam. The Ansible exam also, you can join those other guys also. All right. Tomorrow, 12 o'clock we meet, okay? All right, take care. Okay, bye. Mhm. All right, guys. This is an exercise for 1 minute. If you are not yet done, I see controller C. Arnold, I don't see your name. I don't see your host. The host name, it's it's .lab.example.com. That should be the domain suffix. The domain suffix should be lab.example.com. What I see here as Arnold, your host name cannot just be Arnold. Let it be a fully qualified domain name. So arnold.lab.example.com. Yasin, you're not even there. Mimi, I'm seeing note4.lab.example.com. Mimi. It needs to be mimi.lab.example.hub. Yeah. And Felix, the same thing. It needs to be felix.lab.example.hub. Daryl needs to be daryl.lab.example.hub. You need to really write it well. Aris, the same thing. Ashley, the same thing. Amina, are you logged into VPN?
Oh, yes, I am.
Do you have a server?
No, I'm gonna get one now.
Okay. Get it fast before people get it. You see, this one is already gone. All the ones that I pointed out here, they're already gone.
So can you help me come to my
Who is that?
section because
Who is that?
it's Felix 59 Felix.
59 Felix. You see, guys, put your numbers on your servers. 59 Felix. What's happening? 59.
Yeah, when you came to my page, I mean to my terminal, you
Close
blocked
it and open a new one. Close it and open a new one. See, I'm closing it right here. See, I can open a new one, web console. Just do this and do back launch web console. Okay?
All right, sir. Thank you.
Okay. Getting used to some of these tools is also it's important. It might not be too much, but it's important. All right, guys, that'll be it for me today. Any questions? I'll send out the project. The project will be very tedious this time around. Jocelyn, what's happening?
I wanted to know when we change the IP address and the host name, what are we supposed to change to?
When you change the IP address and the host name, then that's fine.
Okay.
You're done with your server. I'll just give work within the week where you do your work on your server. The work
Gifted,
now
please.
will be
I
done
just
on your
join
server.
in. Can I
Pardon?
please share my screen? Can I please share my screen?
Who is that?
Muma.
Muma, what's the problem? Komi,
Yes, sir.
what's the problem?
I'm really confused. I can't
Brother,
even open my terminal.
don't worry.
It's like,
I
God will
just
help
logged
you.
in into the
And then,
VM, so I'm trying to follow the steps now.
okay, that's fine. You can stay behind and ask. I'll leave the Zoom. Those that are there should help them. You don't have a server, you don't have a server. I don't have time to create new servers now.
yeah, I have a server, mate.
I create. Have you taken the server?
I don't
Amina,
have a server.
who is that? I'll create a new group of
Ryan.
servers. I'll create a new group of servers only tomorrow or tonight. It's a bit. I have to clone the other servers. I have to clone the. You don't have the permissions to create your own servers. I mean, You have the permission to build, but I don't want you to build servers, please. Nobody should build a server. I might take that permissions out.
So I need help from my VPN, please.
What?
I need help from my VPN.
What's wrong with your VPN?
I told you it disconnects me all the time.
Are you using Mac?
Yes, sir.
Ah, okay. What are you using? What VPN are you? Linux class or what? Or
Linux class, yes.
Bernard?
No, Linux class.
Linux class, okay. Yeah, that VPN, I need to like, I've even sunsetted it. I don't even use it myself. What I'm using is what I use mostly WireGuard. Sunsetted that one. I just took it yesterday just because I needed you guys to get in. But the new instance, I'll fix it. I already saw the issue. I'll fix it and send. And now you can log and do what you want to do.
Oh, thank you, sir.
All right, guys. I'll be leaving. Phoenix and Alex, do you guys want me to allow the class and go?
Yeah,
Your
no problem.
choice.
No problem.
Yes, you can allow the class.
Okay.
Can I share my screen, please?
Yeah.
All right, guys. I'm gone. I don't even know who I made host. Let me see.
Alex, you are host now.
Okay.
Host
So
disable
the
participant
YouTube,
screen sharing, so we cannot share.
All right, let me
we are
stop.
still on.
the
So we are
YouTube.
still on YouTube.
Okay, let me stop. Oh no. Stop share. Alex, can you give me back control? Or let me take back control.
Let me give you back if you want. Okay.
Yeah, so I can stop the streams. Did I? No, I stopped it. It stopped already, right?
No, it's still going on.
You gave me back?
Still running on YouTube.
Yeah, give you back.
Okay, let me see.